Philippines. I will talk on advanced metering infrastructure EMI for water meters. Engineer Kada is a graduate of electrical engineering from the UP Diliman. He holds a master's degree in business administration from the Ateneo Graduate School of Business. He is a registered electrical engineer and senior vice president and country manager for ADMI Philippines. He has more than 10 years management and implementation experience in the fields of advanced metering infrastructure, EMI, automated metering reading, EMR, and process automation and controls. Let us welcome Engineer Inaro Kata Jr.
Thank you very much for that introduction. I hope that I am worthy of that introduction. So again, like the other speakers, I would like to thank everyone for staying and listening to our presentation. So as was mentioned, my name is Jude Kada. I'm the Senior Vice President of EDMI Philippines Incorporated. And unlike most of the speakers that came before me, our company is fairly new in the water industry. So what EDMI Philippines is, we are a subsidiary of first agenda, the company introduction. We will also discuss AMI principles, AMI features and benefits, and finally AMI components. So I'll try to finish this within the time allotted, but if there won't be enough time, I have posted in all the slides, I have posted my email address down here. Sometimes appears down here or up there. So you can just email me if there are any questions or any concerns that you would like to discuss. Next slide. Okay. So again. Okay, next slide. So as I mentioned, we are part of the Osaki Group. EDMI Philippines is under the EDMI Limited Group. And this is a company that was formed in 1978. It is present in 14 countries. It has 5 design centers, 4 manufacturing plants, and we have 1,500 employees as of 2020. So we are not a maintenance company in the sense that, of course, we manufacture meters, but we are more of a solutions company. So the products, the meters, is a byproduct of our solution company business. So we are a member of the Osaki Group. It is fully owned by Osaki Japan. It is listed in the Tokyo Stock Exchange and was established in 1916. We have our manufacturing plants. We have manufacturing plants in China. We have one in Singapore, in Malaysia, and also in Indonesia, and also a manufacturing plant in Australia. Next. So we go now to the crux of the presentation. What is advanced metering infrastructure? So advanced metering infrastructure is an integrated system of smart meters, data management systems, communication networks that enable two-way communication between the utilities and the customers. So the benefits that it gives the customer, basically, I will just summarize it. It's just a system whereby the meters gets to talk to the servers so that data is available on the usage of the customers. This data can be used probably to educate the customers on how they're using their meters, their resources, particularly the water resources. And yeah, with this data, they can try to find ways to save on it. And yeah, and on the other side, the utility company can use this data to better serve the customer. So I've outlined here the different benefits from the AMI system. There's a billing. You can have a choice of billing date. Because AMI does not only involve water meters, it can also be used for gas meters in other countries. And particularly in the Philippines, we have a lot of experience using AMI in electricity meters. So in electricity, when you charge the rate, you can charge it on a off-peak or on-peak state. So probably at night, the electricity charge might be lower than this is in the morning where there is more demand. So you can give an option to the customer in terms of the choice of the billing date. So there will be no estimated bills because the data that they're getting is being given to them in real time. You can look at month-to-date billing instead of just finding out at the end of the month that this is the water consumption that you have. Even in the middle of the month, they can know this is how much water I'm consuming, and I'm expecting to pay at the end of the month this much amount. And you can also do a projected month-end bill. Pricing, choice of flat price or dynamic pricing, as I mentioned earlier, you can implement off-peak or on-peak. I'm not sure if that's applicable in water, but in electricity, that's one way to encourage people to use electricity during off-peak hours. Outage handling, what we can look at this is, for example, there's a leak or there's a bursted pipe in the water system. Even before the first customer calls you, you can already find in your system that there's an alarm that tells you that there's a concern on the busted pipe that you need to address. Usage information, of course, if the data is available in the system, you can read the data anytime, and it's available both to the utility company and to the customer. First call problem resolution. Even as I mentioned, even before the first customer complains, you already have the knowledge that there is a concern because the AMI system will alarm you on that one. And even before they call, you're already dispatching your service personnel to address the concern. Web data access, of course, this is an automated system. You can send this information to the customer's cell phone, or, for example, your engineering manager's cell phone, so that at any time they can be prompted on what to do. So yeah, there's more information available in the monthly data. It's just not your consumption. I mean, not only the consumption, how you're using the water on one day, or using a lot of water. These things can be integrated because the information is there. Baseline threshold alarms. If there's low consumption, you can set the alarm to mention you of that. Probably that will get indication there's a leak somewhere in the system, or probably there's an indication also that a main pipe burst somewhere in the system. Month-to-date usage, as mentioned earlier, even daily or hourly data can be taken from the system. Next slide. So the benefits of MI users to the water utility. So earlier it was the customer, now the water utility. Go ahead, please. So enforcement. Of course, tampering is one issue that we need to address, and there are ways for the AMI system to detect these instances. Next slide. Demand management, of course. If you have the data on how much water is being used, you can program your demand management. Next slide. And forecasting. This can be embedded into the system, so they don't have to get the data and analyze it using an outside software. Next. So regulatory requirements. In the field of electricity meters, this is becoming a trend. In other countries, this is already a requirement. I would expect that in coming years, this will be also a requirement here in the Philippines. I'm not sure if the water industry will follow afterwards, but because of the benefits to the customer, this might be something that would be required also of local utilities. System loss reduction. Of course, if you detect leaks early, you can reduce your system's loss. And archiving for historical analysis of data. So AMI components. Basically, there are, in terms of the components itself, there are three components. One is the smart meters. It can all be water meter. It can be an electricity meter. It can be a gas meter. In some installations, we incorporate these 3 meters into one AMI system. So the central processing is being accessed by the building management. So even if they can do the billing, even in just one bill, they can put all the information there. The water consumption, electricity use, and the gas consumption. Of course, in the Philippines, it's not very common to have gas meters, but in other countries they do. Then you need a communication system to send the data from the meters to the head-end system, which is the software solution that collects the data. Next slide. Next slide. Okay. Another click, please. Okay. So here we have samples of smart water meters that are being used. It can be retrofitted into a mechanical meter. Is available in the IM meter and also, of course, in ultrasonic meters. In terms of data transmission, available options are lightweight, machine-to-machine, also radio frequency. A common radio frequency mode of communication right now that we're using is the NORA Alliance. Also MPAS for both wired and wireless, and quite recently NB-IoT. Another click, and finally the data display analysis can be done by the head-end systems in conjunction with the GUIs like Clarity and Mira. These are TTMI brands of Edmi. So earlier, those were very generic benefits for customers and utilities. But we're now we're bringing down to the EDMI products now. Next slide. So this is a typical system that we would employ in particularly in buildings, usually in malls. We have some proof of concepts now within the Philippines, in Manila, where we integrate the smart water meter, the smart gas meter, and also the smart energy meter into one AMI. And the building administration can access all this data and train the building faster. Because in, for example, in a 5,000 room condominium or a condominium complex, you say, there won't be enough people just reading those 5,000 meters. And that's meters for the water, for the gas, and for the energy. So it's just going to be handled by the system, and this will be automatically billed to each tenant. Next slide. Yeah, so going further, drilling down to the actual components being used. So we would have smart water meters here. These are the green ones. And it is being communicated through the radio frequency gateway, data concentrator. And from the data concentrator gets sent to the head-end systems. And the head-end system is the one that collects the data and manages the data and sends it to the cloud database. This is being accessed, a consumption report is being accessed either by the water utility or the facility manager with the building. And of course, the consumers themselves would have direct access to this data, either through the server or directly to the cloud database through their desktop computer, their tablet, or even their cell phones. Next slide. This is a sample video capture of a typical billing information that one would get from the system. So you can hear the record number. This would correspond to 1 meter, and the date time where it was taken, and also in this instance, this is the energy. You can see here that every 15 minutes there's a reading of the energy. So whether that data would be useful in that resolution is up to the consumer or the utility company who will provide the service. Next slide. So AMI best global practice. So there really is no argument on whether we're going to AMI. It's going to happen sooner or later. What is being practiced to make sure that we achieve or that we are successful in our AMI are the following. First slide. So there must be number one on customer buying. The first one that needs to be convinced is really the consumers. Because if they don't buy into that, the regulators will get it and they will tell the utility company to go back to the manual way of doing things. That's why it's very important. Initially, I mentioned the benefits to the customer in my earlier slides. Consider the total cost of ownership, of course, these are the financial items. Consider the term of investment, service scalability. Start with a small system and build it up from there. Because it's very hard and it's a big double if you put in a lot of money, a lot of finances, a lot of resources in a system that there's a possibility that the market will reject. Functional scalability also. You need to take in new applications. For example, every year there's a new communication scheme that's being used. Before it was just RF, then came 2G, 3G, and now we're the year of NB-IoT. So the system must be able to adapt to these new technologies. Standardization to allow multi-vendor implementation. It must be product agnostic. So if you have a system, you need to have a system that will accept several brands so that you will not be beholden to buy the same brand every year. If you need additional 1,000 water meters, you must not be going after brand X, even that brand X is our brand. Of course, that will be beneficial to us. But from the point of view of the utility, you must be able to be given that flexibility to consider other brands to connect to the system. Must be future-proof, as mentioned earlier. Next slide. And yes, number one consideration here is security features. And the communication protocols, they have their built-in security procedures. And this is being upgraded every year almost and upgraded every year by the organizations of communication. And finally, good government regulator support. So everything will crumble if the regulator is against this. So apart from the consumer buy-in, the regulator has to buy it also. Next slide. Okay, please. Okay, in my project process, first is determine how AMI will benefit. So it will always be from the point of view of benefit of the consumer. Next slide. Find out what the available technologies are available. So, go the different communication, data storage, and data management options. This changes every 6 months. So, you need to be flexible when considering this. Next slide. Assign a monetary cost for each option and determine the ROI of the total cost of ownership. So, that's the financial analysis. Carefully screen prospective vendors. This is the bidding stage already. And information dissemination on AMI with water district staff and consumers to obtain feedback. And only after getting that feedback, we will actually go into budget, procurement, and implementation. This is a model that's being used for AMI, not only the water districts, but also the energy meters also. So this has been proven to work. So hopefully this will be also considered if you're considering going into AMI. Next slide. Okay, another click. So yeah, I'm going to wind down a little. Basically, this is now very company centric. This is our company. What we manufacture, we're very big on electricity meters. This has been our initial foray into the AMI field. In the Philippines, we are very dominant. Supplying of electricity meters. We also have water meters, and not only the electronic type, we have the ordinary mechanical meters, the multi-jets, and the volumetric meters, and we also have our gas meters. Next slide. And this is an example of our latest ultrasonic model. This is the WD-280. This is an ultrasonic meter that was developed in conjunction with a an existing manufacturer of meters. So we don't manufacture all the meters ourselves. Even our electricity meters, we sometimes partner with the ODM. In this case, for for this water meter, we partner with a Chinese ODM, and we are selling this to our customers in basically Australia and New Zealand. Next slide. So in the Philippines, we sell this multi-jet volumetric. We have quite a lot of customers already, and the more advanced ones, the advanced smart meters, usually our market here is the Australia and New Zealand area. Next slide. Okay, so this is some of our project reference. For smart water meter engagement, we are currently engaged in project rollouts with Southeast Water New Zealand, Sydney Water New Zealand, and Water Care New Zealand. We have formal trials with Water Corporation in Western Australia and also PUB Singapore. And in the Philippines, we're selling a lot of mechanical meters to Parkpan Water District, Tagaytay Water District, but now they're with Prime Water. Anyway, also with Inupakan and also with the Water District. Among others, there are other cannot business down on all of them. Next slide. So this is the just get my coding again so that I'm accurate. So this is our smart meter. Right now, we're selling this in New Zealand. Of course, this can be imported here in the Philippines. This is 20 mm. So this is of the usual size that we use in the Philippines. So yeah, so these are our. This is the feature of this smart meter. It has interval totals. We have configurable intervals 5 minutes to 1 hour, even 4 hours. We have daily register, fixed time. We also have daily register. We have optional pressure monitoring. We can set in a low-high pressure alarm. We have leak detection by checking for zero flow over 24 hours. We can detect burst pipe. It checks for excessive blood and sorry, not excessive flow, and this is configurable. We have several alarms for temperature, reverse flow, and low battery, cover open alarm, and physical countering switch. We have transmission interval 1 hour, 4 hours, 6 hours, 24 hours. We have the communication is to narrowband IoT. We have full over-the-air firmware upgrade. And the security is implemented to encrypted data transmission and private VPN. Next. So these are some destinations that we did in New Zealand. These are compliant to the relevant specifications that are applicable to the company. And I'm sure that we can also manufacture one that will be compliant to local regulations in the Philippines. Next slide. So they just put here in bullet points the ones that I mentioned earlier. Next slide. Yeah, some more pictures of the meter. Next slide. So this is a cutaway of the meter. You can see here the NB-IoT antenna and also the batteries that we're using. Next slide. So more pictures of the meter. I think I'll wind this down. I would like to thank everyone for listening, being quite patient with the presentation. And if there are any other questions, I mean, as I mentioned, I put my email address there. I mean, they just send me an email and we'll get back to you. Thank you very much to everyone.
Thank you, Engineer Carla. Our next speaker is will talk on sustainable water solutions for an island tourist destination, Mr. Joseph Michael Santos. He is the General Manager of Sunlight Hotel and Resorts Incorporated.